All right, this is the first part of the Trig 4.2 notes, and this should be pretty straightforward. We're going to talk about using inverse trig functions to find angles. Remember, that's what they're used for. We can go from the ratio back to the angle. So we're going to look at example 1, where we have an angle theta that we're trying to find. Look at example 1. Solve for the angle theta. So theta is down here in this corner. And based on this angle, this is the opposite leg over here. This is the adjacent leg here. And of course, here's the hypotenuse across from the right angle. So what we have is we have an equation that we can write down. Cosine of this angle, remember, cosine is adjacent over hypotenuse. So I know that the ratio for the cosine is 9 over 12. The value of the cosine of theta is 9 over 12. Then I will undo the cosine by doing a cosine inverse. And you can do it this way if you'd like. Cosine inverse. If we do that to both sides of the equation, we have this. Or if you want to just go directly to, let me fix that a little bit. If you want to just go directly to theta equals cosine inverse of 9/12, that's totally okay. And you can reduce the fraction and make it a 3/4 if you want. And that's not a bad idea to look at that as 3/4. 3/4 is not one of our cosine values that we recognize. It's not one of our common angles or our special angles. So we are going to grab a calculator, and I'm going to get this answer in degrees. So I want to make sure my calculator is in degree mode. Usually I want these to be in degrees when I'm talking about triangles. So I'm going to put it in degrees. And I'm going to find the value of cosine inverse of 9 divided by 12. And what I have is 41.41 degrees. So theta equals 41.41 degrees. And then, of course, if I needed the other angle up here in this corner, I could just subtract theta from 90 degrees because this angle and theta have to add up to 90 degrees. All right. So as it says here, knowing the measure of one acute angle in a right triangle, we can easily determine the measure of the second because those acute angles are complementary. They have to add up to 90 degrees. Or if you just remember that the sum of the three angles is 180, you're good to go because 180 minus 90 is 90, and it'll all work out. Okay, so as it says in an earlier section, we learned how to solve equations like this and like this. We just use the unit circle to do that. Theta is one of our nice angles, and t is one of our nice values. But today, what we're going to do is we're going to find angles that are maybe not so friendly or not so common or not the special ones that we've talked about. So sine of theta equals 1/3. We're going to solve that. Tangent of t equals -2. We're going to solve that. And we're going to use the inverse trig functions to do that. Okay, so let me move that out of the way a little bit. And I need to extend the page. So this is going to be pretty straightforward and easy. If sine of theta is 1/3, then theta is going to equal the inverse sine of 1/3. But notice that it says find all angles theta. So I have to be a little bit careful. So theta is going to equal sine inverse of 1/3 plus 2 pi times k. That would give me angles that are in the first quadrant, but remember there are going to be solutions that are also in quadrant 2. So these give me first quadrant angles. I also need to, like I said, look at angles that are in quadrant 2. So remember how this works with our with our reference angle. So if this is our first quadrant angle, right here, I have another one in quadrant 2 that has this same reference angle. So that would be, this green angle would be pi minus sine inverse of 1/3. But then if I add any multiples of 2 pi to that, I will have the other solutions. So those are the solutions where k is any real number. Not k any real number. K is any integer. K is any integer, positive or negative. And we've worked with these kinds of things in the past. Now, if you needed a decimal answer for these, you could grab your calculator and you could do, let's say we just needed the values for theta that are between 0 and 2 pi. So what if we just, and you'll have some of these in the homework, where you just need the solutions that are between 0 and 2 pi. So if I did that, I would use k equals 0 in the first and the second. And so I would just grab my calculator. And now I want them in radians, though. So I'm going to switch the mode back to radians, because here we're going to want radians. Just watch watch what it asks you for in the homework. Sometimes with triangles, a lot of times we want degrees, but for these problems, example 2, we're going to do radians. So I'm back in radian mode. So I'm going to do sine inverse of 1/3, and I get 0.3398. And then just pay careful attention to the directions on what you need to round to. So for this one, theta would be 0.3398. And let me fix that a little bit. 3398. I'm just doing some extra things that are going to show up on the homework. I'm actually done right here with what they asked me to do. I'm going to also do my other solution that's between 0 and 2 pi. I'm going to grab the calculator. I'm going to do pi minus sine inverse of 1/3. And oops, that didn't quite work. Because I would put a multiplication sign in there. Pi minus sine inverse of 1 divided by 3. Okay, and I get 2.8018. 2.8018. And you will need to do some like this in the homework. Okay, so for part B, find all real numbers t for which tangent of t equals -2. Well, what I need to do is t equals tangent inverse of -2. So t is the angle. So to find the angle, I do an inverse trig function. So that will get me back to the angle. So t is tangent inverse of -2. And if I needed a decimal approximation, I can just grab my calculator and do tangent inverse of -2. But remember, tangent is negative in quadrant 2 and quadrant 4. And those are going to be 180 degrees apart, or pi radians apart. So my other solutions are actually going to be and because tangent is periodic with period pi, tangent inverse of, -2. Don't lose that negative. Tangent inverse of -2 plus pi k, where k is any integer. And we are actually done right there. And I'm not going to do anything extra with this one. But if you had to have decimal answers, you could find them. You could find your second quadrant angle by doing Oh, actually, I can't. Maybe we should talk about that. Tangent inverse. Remember, tangent inverse only gets me angles that are between negative pi over 2 and pi over 2. So if I do this, it's going to come out to a negative answer. If I add pi to that, I can get my second quadrant solution. So my second quadrant solution will be 2.034. Okay, so if you had to have decimal approximations, 2.034. And if I add another pi to that, I'll get my fourth quadrant answer. 5.176 would be my fourth quadrant answer. So you have to remember how the tangent inverse works. It only gives me answers between negative pi over 2 and pi over 2. So if we are asked for solutions between 0 and 2 pi, we're going to have to adjust a little bit. And that is the end of this video.